Hey guys, so today we are going to be solving lead code 978 longest turbulent subarray. So here we will be given an array. We need to find the longest turbulent subarray. So what turbulent actually means here is that the adjacent elements must alternatively be greater than or less than their adjacent elements. Okay, so let me take this example and show you guys what it actually means. Okay, so here we need to have an output of 5. Okay, so we need an answer of 5. So here we can see that 4 is less than 9, 2 is less than 4, 10 is greater than 2, 7 is less than 10, 8 is greater than 7, 8 is equal to 8, 1 is less than 8, 9 is greater than 1. Okay, so here as you can see, we have the maximum alternating elements with greater than or less than their adjacents is 4. Okay, so totally we have 5 elements, right? So this will be the subarray of length 5. So we need to return the length of the subarray. So it's pretty much straightforward over here. As you can see, we need to find the elements with their adjacents less than or greater than their adjacent elements, right? So off the top of my mind, I can think of two approaches. So one would be to start at each index and check the subarrays. If it is satisfied those conditions, then we can just continue. Otherwise we can just stop and we can resume at the next index. Okay, so this is going to be of n square complexity, and I think it can pass the test cases. As you can see, the constraints are pretty low, so I think this solution would pass these test cases, but we are going to be moving towards the more optimal approach. Okay, so here what we can do is we can 2 is less than, yeah. So as you can see, we need to have some kind of mechanism to just get this, and as you can see, I was able to find the answer in just a linear traversal. So once I find these polarities, then I can simply get the answer in one traversal, right? So that's what we are going to do. So the approach here is going to be a sliding window technique. So we are going to start off with our, let me just quickly erase these. So we are going to start off with our first element, and let's say we call this I, and of course in any array we are going to have at least one element. So the minimum answer that we can have is 1. Okay, so this is kind of an edge case. So if we have our ARI dot size is equal to 1, then we can just return 1. Okay, so we are going to start off with 2 pointers, I and j. So j is always going to be, so we need 2 elements to compare, right? So I and j are going to be two different, pointing towards two different elements, not the same. So basically in sliding window we usually start off with I equals to 0 and j equals to 0, but this is a slight modification in that, so we are going to start off with different indices over here. Okay, so we'll simply we can just check our conditions. So let me just erase this. We can have a flag or a previous kind of a variable which in which we can store the previous polarity which we observed, that is greater than or less than. So initially this is going to be empty, so it is important to initialize this with empty so that we can get started with. So here our previous would be empty, and we can observe key j is less than 9, so we can see ARR of j is less than AR of j minus 1, and we can see previous is not equal to less, right? It is currently empty, so in this case we are just going to assign this. Okay, let me just write it down in a more presentable way over here, so we can directly replace it in the code itself. So okay, so here is our first case that we are going to check if ARR of j is greater than ARR of j minus 1. Okay, so here we are not comparing with I, but we are just going to check with j's previous element, because we are just maintaining I to get the length of the array. Okay, so if this is the case, and we don't have our previous not equals to greater, then we can just increment j, right? And we can update our previous to greater than. Okay, so this is going to be our case 1. Another case would be just opposite one, right? AR of j is less than ARR of j minus 1, then we can simply, and here we need to check if previous is not equals to less than. So in this case also we can just increment j, and we can have previous is equals to less than. Okay, in the case of in case if we get equal elements, what we can do is of course we need to get the answer at every step over here. So in both the steps we can have answer is equals to maximum of answer comma j minus I plus 1. So this would give us the length of the subarray, and here if we come across this scenario, so here it is 8 is equals to 8. Okay, so here what we are going to do is we are going to bring our I over here and j over here. Okay, so case 3, if ARR of j is equals to ARR of j minus 1, then I'm just going to bring I at the j index, and j I can just make it as I plus 1. Okay, and prev I can again reset it to an empty character. So if that's not the case, then we can just have I pointing towards this element, right? If that is not the case, let me check. Okay, so here we can observe this. 4 is less than 9 and 2 is less than 4. So in this case we can just start off with this. We can bring I over here and we can just bring j over here. Okay, so in that case we can just bring I equals to j minus 1 and we can set it to null. Yeah, this seems like a good approach, and we can try it out while rj is less than n. Okay, I'll quickly show you guys the code. Okay, so here's a quick overview of the code. Yeah, it's pretty much identical to what I've jotted down, and yeah, we are just going to take our answer at whenever the condition is valid. We are just going to update our answer, and if both elements are equals, then we can shift our I to j and j to j plus 1, else we can just shift our I to j minus 1. Yeah, let me know if you guys have any queries on this. I'd be happy to help you out. Yeah, thanks.